Hello, I'm Eric Christian, and my project is the Vision Aware Smart Assistant, or now Alexa can see. And it's been a dream of mine to always, or for quite some time, to have the smart assistant in my home not only be able to speak to me and interact verbally, but to interact through vision and for us to be able to talk about things that it sees. So that is the key focus of this project. So here's an image that shows the typical smart speaker. You'll see an Amazon Echo in here, Google smart speaker, I think Apple's smart speaker, Sonos. They're all in there, and my contention is that these speakers would be even better if they had a vision component. Imagine if you could ask your smart speaker, did you see the delivery truck today? Or when was the last time you saw the cat? Did the garbage truck come on Thursday? That's one I can't seem to remember. Um, did grandma come downstairs today? All of these questions demonstrate things that could be answered with a vision device. So my project goals to build an assistant that detects objects in real time, answers live and historical questions through voice interaction, integrates with a home assistant for text-to-speech, works cross-platform on either Linux or Windows, and is extensible for future smart home features. So there's a lot of architecture to this project, hardware and software. We have a camera, a microphone, and a computer, and a smart speaker. So the camera is used as the input to the vision model. The vision model's outputs then go to an object log, so that's where it's recording the things that it's seeing. The microphone is used for me to interact with the Vision Aware assistant, and so it's required voice recognition to translate my speech into something the Vision Aware assistant can use. The Vision Aware assistant lives on the computer, and that's where all the processing occurs. And I can actually go in two directions from there. I could go, my desired goal is to go from the computer out to a smart speaker. So I'd like to be able to interact with Amazon Alexa or a Google Home Mini and ask it questions. And the way I can do that is with this Home Assistant integration. In the case where that doesn't work, the fallback is to just use the computer speakers to answer my queries. The key technologies here are Python. Python's the main programming language for the entire project, so all code, including object detection, voice interaction, data processing, integration logic, that's all written in Python. The other key technology is computer vision models, which work with OpenCV to take information from a camera feed and feed it to the computer vision model. Then sort of the next piece of the puzzle is the OpenAI API. There's actually a lot of queries I'm able to do without OpenAI's API, but for the more complex queries, like what's the pattern to the object that I'm seeing, OpenAI is pretty good for that, and it helps with routing my query to be answered through what's in the historical logs versus answering questions that I have through what's seen on the live feed from the camera. Speech recognition, text-to-speech, speech-to-text, that's all major pieces of the glue that helps tie all these things together. The Home Assistant is what's used to make the integrations possible with Alexa or Google or your smart home speaker. So I thought it might be nice to try to see this thing in action. So I'm going to play this, hopefully you can hear it.
What do you see?
Right now, I am seeing bus.
What do you see?
Asking it what does it see.
Right now, I am seeing bus.
So I pull the bus out of the frame.
What do you see now?
Right now, I am seeing truck and bus.
It still has bus in its buffer.
What do you see?
Right now, I am seeing truck.
And now that enough time has passed, the memory of the bus is kind of moved, so I can tell it there's just seeing the truck. Now it's interpreting the van in the back as the truck, but it'll hopefully get this right We'll give it time to clear its buffer out after changing the camera view. Again, this is a lot faster on Ubuntu. What you're seeing here is based on my Windows
What do
machine.
you see now?
Right now, I am seeing truck and car.
Truck and car. So they're pretty good. It's a van, not a car, but that's fine.
Have you seen a school bus before?
I found 434 detections of school bus during before. Would you like to hear all of them, or just the 3 most recent?
So in the last question I
Did you
asked
see a school bus
if it
yesterday?
had seen a school bus.
No, I have not seen school bus yesterday.
Last week, did you see a school bus?
Last week, did you see a school bus?
Yes, I last saw school bus at 3:01 p.m. on Friday.
It's about the right time for a school bus to arrive, 3:01 p.m. So we'll continue the demo, and hopefully you can see side by side the live camera feed with the computer vision models, predictions or detections superimposed on the camera feed, and off to the left I've got a lot of print statements that are showing me what's going on inside the software. Here we're going to ask the assistant about something in the past. So it's got to figure out, hey, this person's asking about an object that's in the past, and I need to go check the logs.
Did you see a school bus last week?
It was just asked, did you see a
I
school
found
bus last week?
434 detections of school bus during week. Would you like to hear all of them, or just the 3 most recent?
Did you see a mail truck on Friday?
Did you see a mail truck on
Yes,
Friday?
I last saw mail truck at 2:11 p.m. on Friday.
So you can imagine how this would be useful if it was attached to your house, looking out the window or looking at the driveway, and picking up on patterns that might be important to know, like when does the mail usually arrive? When does the garbage truck usually come? The school bus, can't remember, does it come at 3 or 3:15? All the moms are going to know the answer to that, but it's nice if the computer vision model can help out with those kinds of things. Okay, as another demo, we can ask about patterns that have been detected in the computer vision's object log. So here you're going to see how it handles a question about, does school bus have a pattern? I'll play, see what happens.
Does the school bus have a pattern?
I don't know if you can hear that. The question was, does the school bus have a pattern?
Does the school bus have a pattern?
Bus detections are most frequent from Monday to Friday, primarily at 7 a.m. Bus detections are most frequent from Monday to Friday, primarily at 7 a.m. and 3 p.m., and are more common.
All right, so that's pretty good. I'm not sure I understand why it thinks that school bus detections are more common in May, October, and January, but it did get the pattern right. The school bus comes Monday through Friday. It comes in the morning, around 7 a.m., in the afternoon, around 3 p.m. So I think it did pretty well with that. So I mentioned the voice interaction is sort of the glue that holds all these things together, connects everything. So I'm using speech to text. So I'm speaking into a microphone that's getting captured and then translated from my speech into text that can then be fed into the Python programming language. Text to speech, so that's sort of the outputs that are getting fed to a speaker and translated into verbalization so that I can hear. And then we have intent detection that's done with the OpenAI API with regular expression fallback. Basically, it just means that the user's query is captured, and then I use the OpenAI's API to determine whether the question is appropriately answered through the camera feed data or through the historical data. So, for example, what do you see? That would go to the live camera feed. And real briefly, I just wanted you to see, at least on my computer, what it looks like to have the historical logs. So it's sort of in the background. I'm showing you the daily logs that are recording the object detections throughout the day. And in the foreground, if you were to open one of those logs up and look at it, you would see that you have some timestamps, labels for the objects that were detected, some sort of count saying, over the interrogation period, in this case a 1 second interval, how many times did it assign that label, and then a confidence score for any one of those labels. So the combined logs enabled queries like, when did you last see a cat? Or what did you see yesterday? All right, so really my main goal of this project was to get computer vision information into a smart speaker like Amazon Alexa or Google Home Mini. The way that integration is done is using the software called Home Assistant. And Home Assistant is free and open source. It's built for people who are into home automation and who would like to be able to use home automation without necessarily having to be hooked up to the outside internet, just on their local network. In my case, I use this so I could hook up to that Amazon Alexa or the Google Home Mini. For this project, I'm doing the Google Home Mini. I'm also showing you Nabu Casa, which does use the internet. It does let you connect to Home Assistant with the internet, and it actually makes the integration to the smart speakers a little bit easier. So I ended up integrating Nabu Casa with Home Assistant as well. All right, let's talk about cross-platform support. I developed the project originally on an Ubuntu machine, then saved it to GitHub, and then took that Git repository, brought it over to a Windows machine, and basically tweaked it, modified it so it would work better for Windows. On Ubuntu, I was able to meet all my project goals. Unfortunately for Windows, I was not. The main project goal, get computer vision out information to be shared through a smart speaker. I was able to do that on Ubuntu. With Windows, I wasn't able to finally get the smart speaker to send the responses out, but I did build in a fallback so that if the smart speaker didn't work, it would just use the computer speaker. So not a big loss, but something I do want to follow up on, because I do want this to be a full integration with a smart home assistant. There were several challenges with this project, some which remain. I had wanted this project to be fully cross-platform, and it is cross-platform. It's just that it works better on Ubuntu. When I go to Windows, as I mentioned earlier, the project goal of getting that vision data all the way out through a smart speaker didn't work, and so I had to fall back to my computer speakers, which is still okay. But I wanted the magic of doing that full integration through the Amazon Alexa or Google Home Mini. The other thing I found with Windows is that just everything ran slower, less frames per second in my computer vision model. Responses take longer, startup times longer for even running the program. So there's a lot of overhead with Windows that I haven't been able to sort out yet. But if you try to rebuild this, I recommend maybe going with the Ubuntu version. I'm going to have 2 GitHub repos of this available. One thing I went back and forth on a whole lot was asking questions, seeing what the response was, and most of the times in the beginning the responses were inappropriate, and so I had to go try to figure out how to code things up, add regular expressions, eventually bring in Open AI API assistant. And it's a lot better than it started out, but I'm sure someone in this class even could make it better than it is, and I'm looking forward to continuing to work on it to keep it going. Okay, so potential future work. I want to integrate and test with other computer vision models. I really want to fine-tune a model based on my own local data captured through my own camera systems, where I'm going to go through the drudging effort of human labeling stuff, but then it'll be better for my house. There are other things that could be added, dashboards, advanced pattern mining, multi-language support, more smart home integrations, and edge device optimization, so like putting it on a Raspberry Pi, for example. Really like the idea of tying it into, say, a light in my house. Like if the mail truck comes, maybe a light in my house flashes to let me know. Or as soon as the mail truck's noticed, the smart speaker announces it. So those kind of things are really what this project's meant to have go forward with.